Hello, good morning. This is Moses. Today I'm here at my friend's workshop, Mr. Oparanya. Actually, he's the one there behind in the background. Mr. Oparanya, how are you? Hi, there he is. He has invited me to come and demonstrate how a precision gyroscope works. That's something that has always fascinated me. So let us go in and use his apparatus. Actually, it's a bicycle wheel that we shall use to demonstrate what a precision gyroscope is. Now, we are inside Mr. Oparanya's workshop. He has given me this bicycle wheel and I want to explain what is a gyroscope. So for those of you who don't know what a gyroscope is, a gyroscope is a weighted spinning disc that is able to maintain its position and orientation. Now, a gyroscope is able to do these two things because of two fundamental principles. That is its precision, and that is the rigidity in space. Precision and rigidity in space are those two principles which are able to make a gyroscope maintain its position and orientation. Precision refers to the ability of a gyroscope to tilt and turn in response to a force that has been applied. That is precision. Rigidity in space refers to the ability of a gyroscope to remain in a fixed position in a plane when it is spun. So that is rigidity in space. So those two principles are the ones that enable a gyroscope to behave in a manner in which it will always maintain its position and orientation. So I'm going to use this bicycle wheel to demonstrate the working principle of a gyroscope. Before I do that, let me explain something. If you have a body that is moving in a straight line, it's going to possess some momentum. If I happen to change the force on that body, I'm also going to affect its momentum. The momentum is going to change. Now that's for a body that is moving in a straight line, in a linear motion. I want to apply the same technique now in a body that is moving in a circular motion, that is circular direction. Now I have this bicycle wheel. What I'm going to do, I'm going to apply some force down here. When I apply some force here, I'm going to cause some torque is going to occur on this bicycle wheel. Now, torque is actually force times distance. If I apply some force there, the body is going to rotate. The angular momentum of this body is increasing. And actually, if I continue to apply more force, the angular momentum of this body is actually increasing in the direction of the torque, like that. So before we do that, now the body is stationary, it's not moving. If I let go, the body topples over. Again, watch, if I let go, the body topples over. Now this is because this body is experiencing some torque. Now torque is force times distance. Now the force that is acting on this body to cause it to topple over is the weight of this. That is, the mass is being attracted by gravity. That's the force. And the distance is the distance, this small distance here that is pivoted from the string. So the body experiences some torque and it causes it to topple over. Now, what will happen if now I give it some force over a certain distance here, what will happen if I give it some force in this direction over this distance over here? Now the body will start to rotate. Now what will happen is this, that the angular momentum of this body is going to increase in the direction of the torque. Now let me repeat that again because it's very important to get that. If I apply some force here, some downward force, the body is going to experience some torque. And this torque is going to cause the angular momentum of this body to increase in the direction of the torque. Now, so somebody will ask, how do you determine the direction of the torque? So, for example, if I spin it in this direction, the body is rotating in this direction. So I use the right hand rule. That is, I take my right hand, my fingers point to the direction of the force the force is going in that direction, so my fingers point to the direction of the force. My thumb points to the direction of the torque. So if my force is going that side, my torque is facing in that direction. So my torque is in that direction, my force is in that direction. Now you will notice that the torque is in that direction, the force is in this direction. The torque and the force are actually perpendicular to each other. So if I apply the force like this, if I apply the force, I'm going to increase the angular momentum. Let me apply some force. I'm applying some force. And then I'm going to let go at this point. Let me continue applying some force there. There. Can you see what's happening? The body is undergoing some precision. The body is undergoing some precision. It's rotating and it's maintaining a fixed plane over here. It's maintaining a fixed plane over here. Now, that is because the angular momentum is increasing in the direction of the torque. The angular momentum is increasing in the direction of the torque. And the angular momentum is actually chasing or is following the direction of the torque. And that's why this body is undergoing this precision. So this is basically how a precision gyroscope works. And as you can see, it is not rotating forever under the same angular momentum, but it is decreasing because there is some friction involved here. So the body is going, the inclination is becoming less and less steeper, and then it's going to stop rotating. It's going to stop rotating because of some friction. It's going to stop rotating because of some friction, and there you have it. See, it has stopped rotating, and that is because of the friction that is involved here. But my viewers, I hope you have been able to learn how a precision gyroscope works with this demonstration that I've used a bicycle wheel to demonstrate what is a precision gyroscope. Now, a precision gyroscope is a very important instrument. It's actually fitted in aeroplanes as an altitude indicator. An altitude indicator has a gyroscope fitted inside it. We also have the heading indicator. It also has a precision gyroscope inside it, and also the turn coordinator. It also has a precision gyroscope inside. So this instrument is very important in all forms of navigation equipments. They usually have a precision gyroscope inside. Satellites that are revolving around the Earth usually have a precision gyroscope inside them. And also guided missiles that are launched to go and destroy some parts, which is very bad. They usually have some precision gyroscope inside them. So my viewers, thanks for tuning in and watching me demonstrate the working principle of a precision gyroscope. Thank you for your support. Watch the other videos that I've recorded, and also support Mr. Oparanya in his workshop. If you need a bicycle, any repairs, you can come visit him. I will leave the contacts down in this video. You can contact him and you can be assisted if you need anything to do with a bicycle. Mr. Oparanya, thank you very much, and I hope that you have learned something, Mr. Oparanya. Have you learned something, Mr. Oparanya?
Okay, for sure, I've learned a lot,
thank
and
you.
I'm happy.
You're happy. You've learned some physics.
Exactly.
Thank you very much. So my viewers, bye-bye. Thank you. Stay tuned for the next video.